multiply, and then simplify if possible. Assume all variables represent positive real numbers. There are no variables in this problem, so that gets you an idea that this is just a really common statement so that you don't end up with the square roots of negative numbers. All right, so multiply. We have a binomial and a binomial. So you FOIL. And I'm going to take my time. The first product is 2 square root of 11 times 5 square root of 11. Now everything's multiplied in here, and we have the commutative property of multiplication that allows us to write the 2 and the 5 next to each other, and the square root of 11 and the square root of 11. Okay, I'm doing this first one really technically, slowly, calling everything out. 2 times 5 is 10. Square root of 11 times square root of 11, this is the product rule, allows us to write it as 11 times 11. Now there's a perfect group of 2 11s inside a square root, so that comes out as 10 times 11, which is 110. Okay. See if the outer product, if we can speed it up a little bit with some patterns. Outer product, 2 square root of 11 times the negative square root of 3. Okay, so what you start to see when you're multiplying radical expressions together is numbers on the outside, like the negative, the 1's invisible, and the 2 can multiply together. And that's by the commutative property. So that would be negative 2. And the numbers on the inside multiply together. And that's by the product rule. 11 times 11. In this case, 11 times 3, 33. There's no pairs. So we can just write it like that. Outer product. Now to the inner product. The inner product, we have 3 square root of 3 times 5 square root of 11. 5. And numbers on the outside multiply together, so that's 15. And numbers on the inside multiply together, square root of 33. All right, last product. We have 3 square root of 3 times negative square root of 3. So the negative 1 and the 3 multiply together is negative 3. And the square root of 3 times the square root of 3 is the square root of 9, which is, and there's your pair of 3's, is 3. So negative 3 times 3. So negative 9. Okay. Now, so we have 110 minus 2 square root of 33 plus 15 square root of 33 minus 9. And we have some like terms, like this 110 minus 9 is 101. And the minus 2 root 33's and the plus 15 root 33's, we have negative 2 of them, plus 15 of them, and 15 minus 2 is 13 of them, plus 13 of these square root of 33's. That would be how you FOIL in this situation with radicals. I hope this helps.